Hello students, let's start the question. Which of the following is the energy of a possible excited state of hydrogen? Excited state of hydrogen. Hydrogen, atomic number 1, and the electronic configuration is 1s1. Yes? So, as we look at the different energy levels which rest for an atom, we are having the very first energy level, that's the ground state, which has a value of n is equal to 1. Then we have the next, wherein n is equal to 2. Then we have next, n is equal to 3, 4, 5, so on and so forth. Yes? Now, when we are talking about hydrogen, yes, hydrogen will have its maximum, population of electrons, or the n is equal to 1, that is at its ground state, isn't it? So at ground state, hydrogen will show its maximum electron population. Yes, what is it? Electron population. So that means that the most possible excitation which would take place would be to the very next available level, and that's n is equal to 2, isn't it? So the maximum excitation would take place from the ground state to the very first energy level available. Yes. So the maximum excitation would be over here. Okay. Let me just So maximum excitation will be from 1 to 2. That is from the ground state to the first one. So the transition is from n is equal to 1 to n is equal to 2. In short, it is trying to say that n is equal to 2 is the most possible excited state. Yes, most possible. So in that case, if we have to find out the energy of this possible excited state, it's very easy, isn't it? So let us do that. Our very popularly known energy mathematical expression is En for hydrogen is equal to minus 13.6 Z square upon N square, isn't it? Electron volts. So that is going to be minus 13.6. The atomic number is 1 and N is equal to 2 square. So that's going to be minus 13.6 upon 4, and that is going to be minus 3.4 electron volt. Now that is the energy of the possible excited state, and that matches with our option number 2. I hope you understood the explanation. Thank you.
Hello everyone. Question is the correct set of 4 quantum number for valence electron of rubidium atom जिसका एटॉमिक नंबर कितना दिया गया है 37 each. So 4 क्वांटम नंबर कौन कौन से होते हैं? प्रिंसिपल क्वांटम नंबर, जिसको किससे डिसाइड करते हैं आप? n से. फिर आता है एजीम्यूथल क्वांटम नंबर, एजीम्यूथल क्वांटम, जिसको किससे डिसाइड करते हैं? l से. फिर आता है मैग्नेटिक क्वांटम नंबर, जिसको किससे रिप्रेजेंट करते हैं? m से. और लास्ट में आता है स्पिन क्वांटम नंबर, जिसको रिप्रेजेंट करते हैं स्मॉल s से. तो रुबिडियम एटम के लिए आपको इलेक्ट्रॉनिक कॉन्फ़िगरेशन चाहिएगी 37, के लिए कितनी आ जाएगी? 36 क्रिप्टो 5s1. तो 5s में देखने हैं आपको कि जो क्वांटम नंबर है उनका सेट क्या होगा? 5s1. तो n की वैल्यू क्या आएगी? 5. s के लिए l की वैल्यू फिक्स होती है 0 आएगी. देखो एजीम्यूथल क्वांटम नंबर की वैल्यू फिक्स होती है. s के लिए आएगी 0, p के लिए 1, d के लिए 2, f के लिए 3. तो s की वैल्यू क्या आ गई? यहाँ से 0. और बात करते हैं l की, सॉरी s की नहीं, l की वैल्यू 0 आ गई. बात करेंगे हम मैग्नेटिक क्वांटम नंबर की, तो s ऑर्बिटल के लिए मैग्नेटिक क्वांटम नंबर की वैल्यू भी 0 होती है. m की वैल्यू भी क्या आ गई? 0. अब स्पिन क्वांटम नंबर में देखो दो वैल्यू होती हैं, +1/2 और -1/2. एक इलेक्ट्रॉन है तो इसके लिए आ जाएगी +1/2. तो जो पॉसिबल सेट्स हैं वो आएंगे 5, 0, 0 +1/2. तो कौन सा सेट हो गया? ये ऑप्शन नंबर 3 वाला. सो थैंक यू.
Hello students, the question given is the kinetic energy of an electron in second Bohr orbit of hydrogen atom is. Okay, so let's see. First of all, we know that the expression between kinetic energy is half mv square. So this is our kinetic energy. According to Bohr's theory, the relation between kinetic energy and the quantum number, that is principal quantum number, is n square. Okay, here n square and h square divide 8 pi square and mr square. Okay, this is the expression between kinetic energy and principal quantum number and radius. Okay, so this is very important relation. Now we can easily calculate our relation between kinetic energy and the principal quantum number that is given is already second. Okay, principal quantum number given is 2 because we have second Bohr orbit. Okay, so let's see here what we have. Initially we have to replace this radius. Okay, we can replace this radius because what is radius? Radius is our 0.529 into n square divided by z. Okay, we can write this 0.529 is, we can write it n0. Suppose this is our n0. Okay, so we can write 0.529 is n0. So radius is what? Radius is n0 into n square, and what is z? Z, because we have hydrogen atom, that means z is 1. So we don't need to write z. So this is n0 n square. Now we have second orbit. Okay, second orbit, that means n is 2. For second orbit n is 2. So here n0 into n square, that is 2 square. So what we get? We get our second, that is second orbit is 4 n0. 4 n0. But we need value of r square. That means we have to square of r. So this is our r. So this is our r for n0. Now we have to square of this r. So square both sides. So what we get? We get r square. R square is 16a0 square. Okay, so this is our value of r square. Now we have to put this r square value in the equation number 1. Okay, now put the value. So here what we get then? Kinetic energy equals n square. N is how much? N is 2. So here we have 2. So 2 square and h square. And here we have 8 pi square and m r square. The value of r square is 16. 16 into n0 square. 16 into n0 square. Okay, calculate this value. After solving, what we get? We get here 4 into h square, and here what we get? We get 8 pi square into m into 16 into n0 square. So it will goes to 2. Then what we get? What we get after calculating? We get kinetic energy. Kinetic energy is now h square divide. Here we have 2 and here we have 16. That means 32. So 32 pi square and m and n0 square. So this is the expression between kinetic energy and our mass and Planck constant. So this is the final expression for n is, this is for n is 2. This is for second orbit. Okay, this is for second orbit which we need to find. So the kinetic energy of electron in second Bohr orbit of hydrogen atom is, so let's check the option. H square 32 pi square m n0 square. So here h square, 32 pi square m n0 square. So which option is correct? Obviously option C is perfectly matched. So option C is correct and rest of the others are incorrect because they have different values. So in the denominator we need 32 because here we have 32. That means which option is correct? Option C is correct. Thanks.
Hello everyone. In this question we have to find out that which hydrogen-like species will have the same radius as that of Bohr's radius of hydrogen atom. Now, for hydrogen atom, the Bohr's radius is given as 0.529 angstrom, and for hydrogen-like species, radius Rn is given as 0.529 n square by Z angstrom, where n is the energy level, Z is the atomic number. Now, let's see for option 1 what will be the value. For option 1, n is 2, and for beryllium, n is equal to 4. Okay. Now, let's find out the R. It will be 0.529 into n is 2, 4 divided by 4. It will be equal to 0.529. Okay. Now let's see for the second option is N is equal to 2 and for lithium Z is 3. So 0.529 into 4 divided by 3 angles 2. For third option N is equal to 2. For helium Z is 2. So R would be equal to 0.529 into 4 divided by 2. This would be the answer. And for the very last option N is equal to 3. For lithium it is N also equals to 3. So it will be radius will be 0.529 into 9 by 3. Now we have only one option which will have same value as that of hydrogen. That is the first option. Our answer would be the first option. This is our answer. Thank you so much.